Good morning, and thank you very much for attending this webinar today. My name is Clive Sandhurst, and I work for Siemens PLM. I'm actually the product manager for the DFMPro for NX product. This is an authorized product for Siemens. It's inside our Siemens price book, and it's available for sale through our Siemens directly and through our resellers. And it is developed by our partner Geometric Limited, who developed the product, the DFMPro product, to work inside the Checkmate framework and work inside NX as a design for manufacturing tool enhancement to NX. So I'm delighted to be able to introduce you to Nikhil Dalvi, who is the development manager and or one of the technical managers for Geometric, looking after DFMPro for NX for North America. We also have on the call Andy Perez, who's business development, helping sales and supporting DFMPro for NX throughout North America. Basically the format of this webinar will be we'll show you a few slides, and then we want to do as much demonstration as possible so you can actually see the product. And then we hope to have a few, maybe 5 or 10 minutes left at the end of the webinar for any questions that we will be able to answer. So without further ado, let me introduce again Nikhil Dalvi, and he will take over and run the rest of the webinar. I hope you enjoy it. Thank you.
Hey, thanks, Clive. So thanks everyone for joining this webinar. So I'm Nikhil Dalvi, as Clive just introduced, with the Geometric America based out of Troy, Michigan. And today in the next 30-40 minutes, what we will be seeing is this DFMPro software solution to address the manufacturability requirements right at the design stage. So as Clive mentioned, we will just walk you through what is happening today as a part of the DFM process, because that process exists even today, and how this DFMPro software is going to help in that process. That is what we will be talking. So very quickly I will run through a few slides, and then we will actually see the software working in the NX platform, and then we can definitely have some Q&A. So at a broad level, as we see, like most of the industries have certain targets, and they are working on certain specific challenges, as you can say, or the focus areas, and quality is one of the very important ones. So when we talk about the quality runs right from the design to manufacturing to service. So if we get any problem at any different state of that particular product life cycle, there is an impact with respect to how this product is going to perform. And the worst case scenario when it comes to the product quality is really identifying that issue in the customer environment, which can lead to warranties and recalls. And we have seen that, and these are some examples, like we always read about some automotive parts being recalled, or even the consumer recalls. We have many such instances. So again, the focus here is like, okay, how we can make this product really at a superior quality and basically don't get into this kind of situation. The other important aspect that we have been seeing throughout the industry, and especially with the US market, that there is a manufacturing skills gap, and that has been widening. So as you see, like there are a lot of engineers coming out of the college, they do not have enough manufacturing experience, and with a lot of manufacturing happening in different parts of the world, if you are not getting exposed to that, you don't exactly know how certain designs are getting finally manufactured. So that gap also leads to some of the challenges, like if you don't know how certain manufacturing operations work, you cannot think about it or foresee how my design should be to address those manufacturing requirements. And the other information which every one of you must be familiar, like as you see throughout the product life cycle, from the concept design till the part is in production in the service environment, any change that happens in the design has a cost associated to it. Because let's say if I have a problem which is detected at the time of prototype, I can go back into the design, fix it, but there is all that process gets repeated. Same thing happens when it is in the manufacturing or in the build environment. So the rule of 10, what the industry analysts and all these people talk about is, if you identify the problem at the design stage, the cost may be X. As you go further, it can become 10X, 100X, and 1000X. So basically what it really tells that if you identify the issue pretty late in the product life cycle, the cost of fixing is really high. So if you generally look at the summary, and after this slide we'll be talking about what exactly is the solution. But just the summary, to summarize what we were just talking, one engineering challenge that we as a product organization, every engineering manager or every engineer thinks about is, I have to meet the project schedule. And any such rework impacts that schedule. If you look at the quality, every issue that you identify later is basically termed as it calls for an engineering change, or that quality basically is not adhered to. So basically how you can manage and improve the quality is one of the important challenges that most of the companies are talking about. Cost controls, this is no brainer. Is thinking about how I can make my product at a lesser cost, how I can manufacture it at a lesser cost. So the aspects like if there is any scrap which gets generated because of certain issues, or any tooling that can be more expensive, is basically adding to the product cost. So how you can identify opportunities to control those, that's something which the industry is really looking for. And innovation is like, you have to innovate to make your products better and to come out with new products in the market. And to get that innovation, you definitely need to spend more time on looking at different concepts, exploring new ideas. And if you get bogged down into all this rework and all the other issues and just basically focusing on getting the designs out, there is little time left for really trying out different concepts. So these are some of the challenges, or just a summary of the challenges that you can think about. And what as a software provider we basically focus on is, what are the possible solutions that we can provide to address these challenges. And one of the shift left, how we can actually get all this visibility right at the time of design. And there are various aspects of it, but if you see, the design for manufacturing is one of the top contributors which can really help to shift left. And that has to be done. Basically, the traditional way of doing design for manufacturing is the design engineer completes the work, and then it gets into the DFM review process. And basically what we are trying to say here is, like, if that is happening concurrently, it can be of great benefit to the company. So with that, I want to move the focus on what exactly is this DFMPro software really helping us in, and what kind of solution it provides to address these challenges. So this DFMPro for NX is a software which is enabling the manufacturability validation for the design engineers. That means it gives you some suggestions and recommendations on some areas of the design which may be more expensive based on the kind of features that it has, and maybe sometimes it is, we cannot say impossible to manufacture, but going to be more difficult to manufacture. And it also provides mechanism for having all the best practices consolidated in one repository which every designer can follow. So it is giving you that kind of framework. It is very well integrated into the NX, so that we will be seeing in the when we get into the actual demonstration of the software. It's seamlessly integrated. So the reason is, like, we definitely want the designers to be having that visibility of what kind of manufacturing issues may be there in my design. So basically we have integrated that within NX, and if you are familiar with the Checkmate, which is another design validation solution within NX, which looks at more of the CAD quality, and DFMPro is really integrated within the Checkmate. So anyway, it is within NX, and if you are familiar with Checkmate, there is a very small learning curve, or I'll say even you can say it's a very intuitive and doesn't need a lot of training for getting started with this DFMPro software. So getting into the demonstration mode now. So basically what we have here is, imagine like I am a designer and I am working on NX and creating the 3D models. So DFMPro has some of the best practices, which are, you can say, the industry best practices related to different manufacturing processes. So if I am creating a part which is machined, DFMPro looks at that particular part for the machining process and gives you the feedback. Maybe it is this milling feature is going to be difficult, these are the cutters which are not available, or maybe you have to procure some different tools for that. That kind of feedback is given to the designer. And most of this, what we call as knowledge database, is coming from the downstream people, like the manufacturing suppliers, the design handbooks, and the standards governing bodies who have written all these standards or the best practices related to manufacturing. So finally, the objective here is, once you go through this process, the design which is released is really ready for manufacturing, and you are already aware of certain things which you can then have a discussion with manufacturing on and make this design to manufacturing more efficient. So we talked about the challenges, but where DFMPro is really helping is for getting all this validation done upstream. That way you can improve your efficiency, have one repository of your knowledge, and capture the knowledge from the experienced folks who have all the best practices knowledge there, and reduce the rework. And as I mentioned about the Checkmate and DFMPro, just a quick view of that, like, it is unified design validation framework which comprises of Checkmate, which looks at all the modeling best practices, and DFMPro looks at all the manufacturing process specific best practices. So with that, I'm going to jump into the actual demonstration of the software, and next 20-25 minutes we'll be looking at how exactly this DFMPro is helping in the manufacturability validation. So let me jump into the NX now. So here is an NX model which you have on my screen here. Now, in any product companies today, it's not like you are creating only the sheet metal parts or you are only creating machine parts. There may be, it's always a consolidation of multiple such parts coming together to make a complete product. And that's why the DFMPro has got different manufacturing processes and the corresponding best practices which are laid down here. So as you see here, within NX, DFMPro is just one of the menus. Once you install DFMPro, this is how you are going to see that in action. And as we see here, like there are different processes which it covers, including casting, injection molding, machining, sheet metal, tubing, and we are also getting into areas like additive manufacturing, which is more like a 3D printing. And that's the progression that is happening. And we'll be talking about 2 or 3 processes today, but you can imagine like there is a wide variety of manufacturing processes which are already being covered in this DFMPro. Now, this particular, you can say a product or maybe a subsystem which comprises of multiple types of parts, which has got like this is the machine part, which is going to be cut from a block, and that will be like, there will be mostly the milling and drilling kind of operation. Then we have a plate here, which is like a sheet metal plate, and that is basically having all this PCB assembly, which is maybe it is imported like a step file from another maybe ECAD system, and that sits on top of that plate, and then there is a lid which is basically a plastic cover making this complete unit as a complete subsystem or assembly. So with this, let's say if I want to run, I mean there will be different design engineers working on different parts of this system, and let's say if I am a designer working on this machine part. Now this is a part which will have to be cut from a block, and let's say if I want to see if I am making the correct design here, obviously the form, fit, function, as a designer I will have to take care of it. But now I am really interested in looking at, okay, having done this part, now is it really going to be good for manufacturing? Can I send it out immediately? So at that time you can definitely look at, okay, now let me see and what this DFMPro is going to tell me about this particular part. So if I go to DFMPro, there are a few things, steps you have to select, and basically it has got the rule file, which we were talking about, all the best practices which are covered as a part of in that particular rule file. So this rule file comprises of all those best practices, and there are different rules which you can see here like milling, drilling, turning, casting. So there are various such rules which are there. And if I want to look at any one of them, it is talking about, let's say, deep radius corner. Now, these best practices are derived from, as I mentioned, right, from some design handbooks or some standards which are already available. So, but these specs can also be changed based on your company needs. So I can always make a change here and say in my types of parts, I have to have this milling tool length to the radius ratio to be 12. I'm okay with that. And when I say, okay, this rule file will have to be, then it becomes like my standard. So it comes with a default, all rules which you just saw, like it is pre-packaged as one single rule file. But then I can define that, okay, this is my company DFMPro standard, and I can run those analysis with my standard. So this is how you can define your rules. We will come back to these rule definitions after we see how it really works. But the point here is like the rule file is one of the inputs, and typically that is the first step in any organization when it comes to the deployment of the solution. So you have the best practices coming with the software. You may want to tweak a few and make sure that, okay, this is my rule file which I want to use for all my design guidelines. Now, having defined that rule file, now I want to see whether my part is going to be easy to manufacture. So now this is going to be my machine part, so I'm going to say, let me run this prismatic mill analysis on this, and let's see what it comes out with as a feedback. So when you run this analysis, the DFMPro software basically identifies all these key manufacturing features. So for example, I got all these pockets here, I got some holes and cutouts. So these are identified as the manufacturing features, which will be either machined using milling operation or drilling operation, whatever the manufacturing process is. So the way it works, it recognizes all these manufacturing features using our own patented feature recognition technology, and then the corresponding features, like for example, I'm talking about this pocket. So that pocket will need to have some requirements for, like, I have a standard milling tools available or milling cutters which are available. Can I machine this pocket very easily? So it will look at that pocket with respect to the milling functionality and the best practices for milling. So likewise, it basically identifies all these kind of manufacturing features and the corresponding manufacturability validation, and it comes back with this kind of result here. So this interface, as you can see, it's a completely checkmate interface, HDCD interface, and it has got this kind of red flags and some warning flags here. And if I want to look at some of those in detail, I can always see, okay, it shows me that there are some sharp internal corners in this part. Now, as a designer, I typically make sure that, okay, I have got all these radii and all these blends are applied, but still there is a possibility that I can miss something. And if I go here, I can right click and I can zoom into that region, and it tells me this is a sharp corner here. Now, this is something which probably I missed during my modeling. So at least once I see this, then it becomes very easy for me to really make sure that I don't need this sharp corner. Is this something which I need as a functionality? Is there something which I can get rid of that sharp corner so my manufacturing folks don't have any problem? Then I can always go here. I'm in NX. I can always go to modeling, and I can always add the blend here, and then I can rerun this analysis, and it will be gone. This issue will not appear here. So likewise, I can go into these details where I'm getting more such feedback. So here is another example where there is no blend on this side. There is already a blend which is applied on one side but missed to apply on the other side. So you can catch these things very easily. And again, these are some simple examples just from the demonstration perspective. There will be many others that you can actually see. For example, you have areas of, like, I have a problem with respect to the narrow regions in the pocket. So if I want to look at those, so if I look at it, basically what it is telling me that I have got a very narrow region between these features. So you can see, like, there is a wall here, and I have got a feature which is very close to it. And to machine that, I'm going to need a very small diameter tool. Excuse me. So basically, it is going to be a very small diameter tool to machine this gap, and that's why it is showing that as a narrow region in the pocket. So likewise, it goes through all this kind of process, and you will see all these reports being generated. Finally, if I want to get, if I want to fix these issues, I can always do it in NX. And if I want to have a discussion with manufacturing folks, that is it something which I have to fix in the design, or because I can basically have some functional requirement, but is it going to be easy to manufacture, or is there any suggestion from manufacturing folks? So there is always an option to generate a report which you can discuss with your manufacturing engineer. So for that, you have an option here. You can actually look at any of these, and let's say if I have got like this fillet on the top edge, and if I want, I'm not aware of this, like why it is flagging that as a problem. It is a blend which I have applied, but if I click on this button here, help, it tells me why I should try to avoid it. Because if I got like a fillet here and I'm cutting it from a block, just for that fillet, I'm going to need either some form cutter to be used. So if I click here, it is going to need some form cutter here. If I had just applied a chamfer, it would have been fine. But this is the kind of information that is basically presented, and I can learn from that process. So coming back to the collaboration, like if I want to discuss this with my manufacturing folks, I can always take a picture of this and basically add some comment that I want to discuss this with my manufacturing engineer, and then take a call on this particular design. So I can click on that, and then I can generate a report from here. So this report is created in an Excel format right now. So if I click OK, it's going to generate a report, and it's running it immediately, and it comes back with this kind of report. So if I go here and if I look at all this, so it will tell me like, okay, this is the problem here. What is the recommendation? So you have all the information here, like this fillet radius is 1 millimeter and actual value is there is 1 millimeter, and you should basically avoid the fillet on the top edge. And you can always discuss that with the manufacturer. So now during the discussion, you can open this report, ask some questions, and then there could be an action like, okay, remove this fillet, maybe an action on the design. Okay. In some cases, this is something which is my functional requirement. Maybe we'll have to procure a form tool for this. But at least you know upfront that what is the action that I need. And then you are basically prepared that I'm going to incur a little more cost to manufacture this, but at least that is a known decision, and you are basically consciously taking that decision. So this is how you can generate the reports out of this. Similarly, you can go into the other, you can go back to your assembly and look at the assembly model itself. But let me very quickly run through this sheet metal analysis. So in the sheet metal process, if you can see here, like I had already run this analysis, and I just updated the results here. So in a sheet metal, different requirements, and for example, here it is talking about like I have got a minimum hole diameter which is violated as a rule. So if I go there, it shows me that particular hole which comes up, and if I click on show info view, it tells me that the hole diameter is 1 millimeter, sheet thickness is 1.5 millimeters. So it is recommended that I should be having at least 1.5 millimeter hole here. So for some reason, if I just want a hole, and if I can change that diameter to 1.5 or more, then it is going to make it easy on the manufacturer. So likewise, there could be many more. Some of the things are pretty commonly occurring even in many of these sheet metal parts, like I have got hole too close to the bed. And this becomes a problem. Like if I have got like a hole which has got some requirement where I'm going to have any deformation in that hole, and if I got a bend here, so typical process in a sheet metal will be like I will make this hole either a punch or laser cut or whatever is the operation that you take, and then you will bend it. So this hole diameter can get deformed. So if you want to avoid that deformation, or if you have some tight tolerance requirement, one possibility, if you have to have it at the right disposition, you will have to at least let the manufacturer meet this tolerance requirement on this hole. So probably it is a good idea to bend it first and then make the hole. But then you are actually definitely making a plan for having that drilling operation after the bending. That means you may need to have a fixture, or you may want to hold a component in some way to make this hole. So, but again, if you get these feedbacks upfront, that discussion between design and manufacturing starts right at the time of design. And that's what we are basically calling that as a shift left. So all these discussions, if you start early, there is at the end of that particular process, when you are getting these designs out to manufacturing, there will be less number of turnbacks or less number of iterations that you will go through. So this is how it works. And again, all the other functionalities almost the similar, like you can generate reports. You can always export these results out, because like many programs, like I am working on this particular thing and suddenly a new job comes in and I have to close this and I have to make sure that I am storing all the information, and then that can be done using export. So I can always export those results out. So this is how it works. And just very quickly going on to the assembly. So finally, or at a piece part level, every designer is that every piece part is taken care of for the DFM requirements. Now finally it has to get together and it has to assemble. So there is also this assembly module which we have in DFMPro, which looks at whether my parts will go together well, whether I have got like all these bolts, bolted joints here, whether it has got sufficient engagement, it has got the right hole clearances, all of that. So it will check for those. So if I run this assembly analysis on this particular assembly, it will come back with all the feedback on how it will basically behave in the actual build condition, whether I will have any problem while repairing this build. Some of the information that it will throw at is like for these two holes, these are not lined up correctly. So this can happen anytime. Basically, if I got like this PCB assembly is being done by someone else, and they move some part here, and basically on the sheet metal part, I have missed to change that hole dimension. It's not aligned here. That can create some problem. It will not fit, and all those assembly issues come in much later in the process. Or some of the things it can check is like if I have got two materials in contact, which may have some corrosive effect or which I should not be using. For example, in this case, it should not be like the steel and this aluminum should not be in contact. Again, you can define what is a dissimilar material or what should not be in contact. That is completely in your control, as we saw in the rule file definition. So you can define those rules and the reason why you don't want them to be in contact. But the software will come back and give you those kind of, wherever there are some instances like those. Similarly, you can see like, okay, there is a minimum clearance requirement. Now, here is a situation where you have got, please zoom into that region. So basically, it is talking about like I have got a capacitor and or this connector here, which is very close to a plastic part. So this is going to basically emit heat. And if I see my plastic lid here is really just 0.94 mm away from that particular heat generating device. So I need to have minimum clearance of 10 millimeters there. So I can always check for that, and then I can make some tweaks in my design or move this part little away. All that can be done, but the information is made available right at the time of design. So that is how it basically functions. And so there are various such rules which are there, and as you see, like there are different categories of it, and you will see like the injection molding, milling, casting, sheet metal. So today we just have time to cover a few of them, but this is the overall framework, and this is how this DFMPro is checking or validating your design against the manufacturing processes, and it is done much earlier. So the idea here is, as a designer, I will like to use this at the time of design, so more often than waiting for everything to be completed and then start looking at it. So that's how this basically tool can assist the design engineer during that design process. So this is what basically the software actually does. So coming back to what we just saw. So one thing is like it has got some configuration as a best practices that your organization may have. And obviously the software comes with the industry best practices, but it is very easy to configure those to make it your best practices. So that is one initial part of the implementation. Once your rules and design best practices are configured, it is deployed for all the users. That means everyone follows one single standard. There are no silos and no different checklists and guidelines for different units. It is one single source of truth. Then it is really easy to use in terms of, we just saw, it is so well integrated within NX that as a designer, I can just take a look at it, go back into my design feature tree, make some modifications, and move on. And finally, it really creates that collaboration between design and manufacturing. And all that collaboration can be basically documented in this kind of report, which we see in this DFMPro analysis report. So it is fairly simple to implement. You can get started very quickly with the best practices which are available within the software by itself. And later on, you can always make it like slowly you can make it as your best practices. So we talked about some challenges earlier. What are the business challenges? So when we see this DFMPro being adopted right at the time of design, what it is really solving? So when it comes to the project schedules, of course, it cannot solve all possible problems related to schedule, but it can definitely make your design review process much robust and efficient. Quality management. It will make sure the quality is a very broad term when it comes to the product quality. But the first step of that is my design quality going to be improved with this software? Yes, that's what it really helps with. Cost control. Even if you can somehow avoid some of those expensive operations or some of the rework that happens, and we did not go through some plastic and casting example where the tooling is very expensive, and any change that you have to introduce into the design can have like a complete rework on the tool, which can get very, very expensive. And if you can control those costs, that can definitely help to drive the product cost down. And innovation. So basically all these efficiency gains that you get using this upfront, that you can always try with different concepts. Like I have some part here. Now I'm running this DFM analysis for machining. Now, can I just check like, okay, if I have to make it like as a casting, what will be the problems for that? You can quickly run the casting analysis on the same part and see what areas of improvement that you will have to introduce in your design and make it suitable for casting. So this is how basically this design for manufacturability can help for all the product companies, and it applies, as you see, like it is really for every manufacturing process that we have. It is not like an industry standard but it is manufacturing process standard. So it applies across the industries. Whether it is aerospace, you have exactly those similar manufacturing process. There are certain configurations which will change per industry or per different types of the parts that you deal with, but it really helps in different automotive, aerospace, high-tech electronics. It really helps any such industry type. And obviously we are going to take questions now, but for any information, if you want to have dialogue or we need more information about this, this is available at the link here, and you can go to the Siemens website on the PLM and you can search for design for manufacturing. You will typically see this page. You can always contact us using that.
Yeah, thank you very much everyone for attending. I hope you got a lot out this this webinar and understand the DFMPro product and the value that it can bring to the design process with respect to manufacturing and reducing manufacturing costs. And thank you very much, Nikhil, for a great demonstration.
Thank you. Thanks, everyone. Have a good day.
Yeah, thank you very much. Have a good day, everyone. Bye.
Bye.